Good evening, friends. Welcome to VSAN Academy. We are going to discuss about C programming as a part of embedded system programming. And this is session 8. Actually, we missed this on the previous C programming. That's why we are continuing today. And in this session, we are going to discuss about structures, unions, and enums. These are the typically not used by the initial programmers. That's why I didn't discuss much. Also, try to understand, but don't try to get confused too much. This is not very well used in the first stage of programming. So first stage of programming is what we discussed. I'll go to the board. So what we discussed previously is the most important one for our embedded system programming. That is the bottom one: declaration, assignments, operators, and decision making. Okay, this is the 4. Then get to the 3. Arrays, strings, and pointers. Then functions. Till you clear this topic, don't move on to the next one. That is what our structures, unions, and preprocessor. Please understand. But some of the preprocessor things will be used here. We will discuss today. The first session, we will discuss structures and unions and enums. And the second session, we will discuss about this is a very, very interesting one that gives you the ability to make a program like a poem. So please understand. So I'm discussing this to cover the topic. Let me be honest. But you understand this. We have already discussed about what is structures, what is unions in our C class, the C language class. And it's very simple. That is actually a data type. We have a CHAR, which will allocate one space of 1 byte, which will allocate 1 byte. And we say CHAR of 10. It allocates 10 into 1 byte. Understand? So that means that we allocate 10 locations in the memory of 1 byte because you are defined char. All of them are character. That is, character mean 1 byte. Now, I want to have a data type which should have a 1 byte, 2 byte, and 4 byte. Now, how do I define it? For that only, they brought a new thing called structure that gives you can say structure, some ABC, understand ABC something. You can say CHAR A, short B, long C. See here. Now you have created a new data type now. You created a new data type. Like int, short, ABC is a new data type. So you have to use like this. Struct ABC XYZ. This is like int A, int M. What you do in here? The same thing here. Instead of int, we have ABC. For instead of short, I have structure ABC. But that's just not, you don't want to put the structure in between. So what our Dennis Ritchie did was a nice thing. He did something called type def. Understand? Type def. I put structure ABC as a, let's call XYZ. You see, understand? Type def structure ABC as XYZ. Now, what you can see in future, XYZ is equal to A. Sorry. XYZ B. Like int A, int B. You can define. Like that, you can define. These are all generally, these are what I'm discussing now are all C language. Now, we have to discuss this. How this is going to be used on our embedded systems programming. That is very important. Everything. How this is, I already discussed previously how pointers are used in embedded system programming. Okay, every C is getting used into the embedded system programming. The same way, let us assume that I have a timer. I have a timer in my microcontroller. I have a microcontroller. Inside the microcontroller, I have a timer. The timer is having a register called count high, count low. That is, this is 8-bit. This is 8-bit. That means that I have a 16-bit timer. 16-bit timer. Then I have a thing called mode. I have a thing called control. And I have another one called status. Understand? These are all the timer which I have about 5 registers inside the timer. Okay. It's all 8 bits. Now, I will declare this as a short. I can do like this. See, I can do like this. See, CHAR, count H, CHAR, count low, CHAR, mode, CHAR, control, CHAR, status. Now you understand. I create a structure. I call structure timer. I have a structure called timer, which has this many values inside the IC. Okay. Is it clear now? So I have a structure which has a timer with a microcontroller timer, and these are all registers. So this is done. Now I define here structure. Let us assume that on the data sheet, this guy is having an address of 0x80, assuming that's the address of 80. Now I say structure timer star timer 0. See that? I put star because it's a pointer. I'm going to assign address now. Now I say timer 0 is equal to 0x80. Done. Now it's done. Now we have to access that. How do you access that? It's quite simple. You can take anything. For example, you want to access mode. You say timer 0 / mode equal to sub 0x30. Something that we will discuss later. That when you discuss timer, you will know that. This is the way it is getting used in embedded. Okay. But I see that here's a count, 16-bit value. You cannot always divide the 16-bit value like this. See here, you cannot write like this. That is actually boring. If you write like this, it's boring. Say that timer 0 count h equal to 0x20. Timer 0 count low equal to 0x10. The actual value is 2010. But since this is 8-bit, we make 2020 separately and 10 separately. But we can make this like this. I can make this a short count. I can write here now easily timer 0 equal to 0x2010. Once again, I'm telling you that just to have this in your mind, these things, how it is used. Till you use it, you will not understand it. Till you are coming to that level of programming the embedded thing, you don't understand this. As I told you that the pyramid, you have to complete up to this to come to the top one. That's why they don't give importance to the structured programming initial days. But I just wanted to give you the thing so it will be recorded. You can see it anytime, whenever you want. That's why I just thought I'll take the class today. But I will also convey you, it's very important. If you say that, sometime your microcontrollers, you go and study the microcontroller. Let us see the small minute. In 1 minute, let us see a data sheet. Then you will know that why I'm discussing this. If otherwise, you may not be able to really understand why we are discussing this. This is a trick, because this is what you're going to see tomorrow when you are going to the next level of programming. For example, you go to the ARM one. Okay, let us go to the ARM. If you take any processor, it's called reference manual. You go to the timer. If you go to the timer, see that. Okay, if you go to the timer, see that timer 1 to timer 8. If you see here, this chip, all the timer they've explained. But if you go to the registers, you see here now is a very important. See here, timer 1 to timer 8. They don't write only one. If you see the document now, once again I make it bigger one. Then see, you need to understand why we are using the discussion here for the embedded people about structures. That has to be understood by you very clearly. Otherwise, you will never understand this. Why I'm discussing this. You see here, timer 1 to timer 8. What are the addresses? I'll get you now. How do you read? These are all. You see, everything is linked. Your data sheet and your C programming, everything is linked. Okay. See here, memory map. You see here this topic. This is what your ARM processor. This is the very lowest end. This is a good processor. See that now. Now, please understand. Even if you don't understand, listen to me. That will be very useful to you tomorrow. Now you see here peripherals. See here. These data sheets are available on your, what do you call it? Our Google Drive. See here, every timer. See here, every timer is having an address. Timer 1, timer 2, timer 4, timer 5. This address is there. Okay, I'll show you now why I'm explaining to you now. I have so many timers. Each timer is having an address. Okay, let us take a number. I'll write it down. I'll show you that. 0x. Let's say timer 1. Let's take timer 1. Timer 2. Timer 2. 0x 400000000. That is address. If you see here, timer 2. Then timer 3. Every timer is having. If you go up, he explained everything, various timers. See, timer 1. Everything will be explained. Timer 9, 10. So you will not miss out anything here. Please understand. All are explained in this data sheet. Now, if you go here, this is what the trick here. You see that the offset is how many bits? 16 bits. And next to offset, see that 04. Next to offset is 08. Understand now? So they have everything here available to you. Now I go back to the this one. Why I've explained to you this. Sometimes we may not be able to really understand why we are explaining now, but later you'll be really understanding the use of this. You need to be always very clear how we are linking all these things. Now let us go that thing here. I have a chip. I have a microcontroller chip. Whatever chip it is, it could be ARM, or it could be your Atmega, or your RISC, or x86, whatever it is, I don't mind. Now, internally, I have so many timers. See here, I have so many timers. They are all same. All the timers are same. Please understand. This could be controlling a motor, one motor. This could be controlling another motor. This could be controlling the LED. This could be used for your internal purpose to microprocessor. So many things. Now, the beauty is all of them are having the same registers. That is what I showed you a document. Timer 1 to timer. Sorry, that's timer 0 to timer 8. Understand? So all of them are same, but there are so many duplicates are available. For each one, you can use it for various purpose. Now I define a structure. See here. Structure. Timer. Yes, I've defined. So that is what I put short. Count. Short. Mode. Short. Status. Assuming you have all the people are having it 3 registers. The trick here is this, how we are using this, very important is, I define here structure timer. This is what the values. I say star timer 0, star timer 1, like that. I'm taking only a 2 now. Now, the beauty is each one is having address. Let us say 0x 4000 4000, assuming. This guy is having 0x 4000 0010. Each one is having a starting address different. That is the beauty of the hardware. Yeah, you can do. Somebody is asked. No, don't ask me the question in direct message. Then I have to read the question to everybody. Ask me in the public. Somebody asks, can we do it on the same thing using a pointer? You can do it without a pointer, you can do it anyway. But the trick is that there are so many methods you can access. But I'm explaining about structures. The advantage of structure is, I can say that when you see the code tomorrow, timer 0, count equal to 45. You know that, oh, Balaji is writing out to timer 0. This gives you the readability. Anybody write your code, you will be able to understand. And you know that in timer 0, I am writing out to the count. If you say that now timer 0 mode 0x01, if timer 0 status. See, I put arrow here because these are all pointers. Since a defined pointer, I'm putting arrow. Status equal to so and so. So the thing is that this gives you anybody to modify your program. Anybody's program can, I do not have to understand this. These are all there, you define. Okay. We will discuss later. These are all the one defined in .h file, header file. That is what next session we're going to discuss. Why these are all useful, what is a new development going on embedded, how you have to adjust to the new world of embedded programming. See here, timer 0, count, timer 0 mode, timer. I do not have to know this at all. If you give me the code, I understand. Otherwise, if I say something else, you will not really understand it. Now, if you want to have a timer 1, I'll say timer 1, count. You read it, you understand it. So the thing is that these structures gives you the ability to understand the whole program, and the name itself is given called structure. So you will understand that what is the structure of the, understand one thing very clear. The moment you say, let's say this is having, let us zoom in this. Let us zoom here. This is having 3 registers. One is called count. One is called mode. One is called status. If you say that structure, timer, short count, short mode, short status. Now, if you put start timer 0, example. If you say start timer 0 equal to, timer 0 equal to, you give an address 0x40000. Now, if we say timer 0 count, he will automatically say 40,000 plus the 0. Now, when I say mode, he will take 40,000 plus 2, because this one has been 2, this is 2. He will do the 40,000, 2 he will write. The trick is that you do not have to worry about what is address, what is the offset and everything. You do not have to worry about that. These things will be taken care by your structure. That is the advantage. So anybody see this today without going to the data sheet. By seeing this in my file, I'll understand how to program that, because everything is names are there. Now you understand that where we use this one, structure. This is one important place we use it. This is one important, there were lots of uses. This is the whole embedded world is today moving to using the structures. If you get into the, you know that today, most of the embedded products are using ARM. When you get into the ARM, you will start using these structures and linked list. Actually, there are two things. You know that linked list is on the software. Actually, you know that it's all in the data structures. Let me explain to you now how the linked list is used here. Now let us take a very real life example. Let me take a very real life example. Then you will understand. I have a microprocessor. I have a microprocessor. I have an internet. Don't tell me these things are not, these things are required for you. IoT is full of this. Embedded system plus networking. So better learn the networking also. Now, I have somebody called Ethernet controller. Understand? There's something called Ethernet controller. Now, what the Ethernet controller will take it is from your memory. From your memory, he will take the packet and send it to him through either wired or wireless or optical. This is what exactly thinking. When the moment you go and type www.microsoft.com, these all things are happening. So please understand, this is the real world. We are getting into the real embedded systems applications. That's how we are using. That's why I told you that first to learn GPIO programming, that LED2 things. Then go to the controller programming. Then go to the interface programming. Then you will start understanding these things very clearly. A lot of people are doing very good. Actually, I'm getting a lot of people's outputs in embedded system programming. Keep doing it. Then only you will know the user. See, if you write in a resume, I have written a firmware for Ethernet controllers. That's it. That's it. You have been considered as a 4 to 5 years experience guy. Understand now, but it's a pretty easy one. Now we are going to explain that how your structure. Somebody may be asking that why I have to study structure. Don't get confused between data structure and structure. Okay, data structure is full software. Here we are discussing about structure in C language. Of course, data structure uses structure. That is fine. But now we are discussing about the structures. The beauty of the thing is, now let us assume, now I'll give you the good idea. You will get an idea also how the packets are going on the internet. Now we all studied about embedded microcontroller. Now I have a controller called hard disk controller and connected a hard disk. You have a MP3 file. You have a MP3 file or MP4 file, which is about 1 meg. Assuming that 1 meg, that is 1,000, 1 million. Understand? This is about 1 million bytes. Sorry. Somebody is saying that C is not used developed by that. That's just a very myth. That is actually Python can never replace C on embedded systems. Still, even today, 90% of embedded systems is used only C. Python can never enter. Python, I've shared an article that day. Why Python cannot be replacing C in embedded? Because Python is absolutely a non-green language. It takes more power, it takes more time, it takes more space and everything. So Python can never. If you want to learn embedded, you do the top level. Oh, I'm also learning embedded Python. You can do that. Okay, I'm also doing something. But if you come to the real product in embedded, 90%, not 90%, remaining 90% could be C++. That's what. But even 95% of the thing is that this all with some college students are discussing and talking about this, who never seen the industry, who had never worked in the industry, are giving this. I lived in the industry till now. Okay. I even C++ is useless. Please understand. I don't know why you are getting confused so much. We are discussing about one point. C++ is useless for embedded system. Otherwise, C++ came about 40 years back. That should have replaced the C actually. It has not done. Okay. Now we are discussing about how C data structures in embedded. Understand? See, I've told so many times, you cannot replace C in embedded. At least for so many languages came. First C++ came, Java came, Python came, then Go. Google has founded the Go language, but nothing could replace C. Please understand. Even today, every college is teaching you only C. Even you'll be very surprised. You may go and work in Python, but the college level, they will do the conductor test on C only. So C is a basic, man. Let me be very, very clear. I do not want to repeat this once again. C is the basic to understand about computer architecture. By Python, you will never understand about computer architecture. You will just do the puppet. You will call some function, import, call a function, and done the work. Okay, that's a different type of scripting language. C is a real bottom level hardware controlled programming is only C today. Nobody can replace C. Please let me not elaborate these answers once again, because I've told this so many times in my class itself. So now what is happening is, let us take a thing. You have a MP3 file. You have a MP3 file which is about 1 megabyte. One megabyte. This 1 megabyte, if you wanted to send it through the net to somebody else, that file is stored in your hard disk. As an embedded programmer, first of all, you will program the hard disk controller and read the data. That is what we call it as a drivers. This is all software. Driver is a software which helps you to take the file. These are all written in C. You can go and read today. The entire Linux operating system is in C. Now they are trying to, this was old C. Now Linus Torvald is trying to convert it to latest C11 standard. They are trying to make the, modify the Linux. Okay. If you want to touch anything, you know that all your mobile phones full of Linux kernel only. Where the Linux driver, no, it's not part of firmware. That's a firmware. Driver is a firmware, please. It is not, it's a type of firmware kind. I saw it part of the thing. It's kind. Driver is a firmware. But only thing is, it sits inside the OS. Driver had two things. Driver, what happened? See, your normal OS, see, let's say I have a microcontroller. I have a, what do you call, LCD. And I have a sensor, temperature sensor. So what you will do here is, in your microcontroller, you will write the firmware. It's very important, this is not only firmware. This same firmware sits in the ROM, read the temperature, and give the display to the LCD. This is a product. You may call this is a temperature monitor. A small microcontroller, a temperature sensor, a LCD. Done. This is called firmware. But whereas the driver is the same thing, a firmware sits in the OS, which gets the command from kernel and give it back to kernel, not to the device, please. It talks to the devices, but it is taking commands from there. It reads the temperature and give it to kernel. And from kernel, whatever it comes, it give it to the display. This is not there. In the firmware here, it does within here. Here, there is somebody else is there to take your hardware and take a decision. Now, what we do here is this microprocessor reads a file from the hard disk, your MP3 file, and put it here into the memory. First job is done. So I moved from the hard disk to memory. Done. So now I can remove this. I don't need this. But very unfortunately, in Ethernet, as per standard, I cannot send more than 1500 bytes. I cannot send more than 1500 bytes. It is because of the Ethernet standard. But my file is how much? 1 megabyte. So what this guy will do, this your software, it will break the file, MP3 file, into small memories. Small memories. Understand? Each one is 1500 bytes. Now, this is stored at some address 1 lakh, and this is stored some address 1 lakh and 2000. This is stored some address 100 3000 4000. It is stored at some various places. Now what happened? Our man, who your Ethernet controller, will take this data from here. Will take the data from here, his local RAM, and send it out. That is what his job. That is what his job, to convert your data to serially and send it. You would have heard about NIC, network interface card. Now you may ask, what is the connection between this and your data structures? This is what the beauty. What people do here is, inside the memory, I create a small structures of the same size. This structure will have a control, status, and what this guy will have here is address. Okay, you may call this, let us call Ethernet address. So this guy, who your Ethernet controller, will read this and check the control packet. Oh, the control packet is 1, then it means that you want to transmit the packet. Then he will go to the address here and copy the data into the memory. Then he will set it to 0. That means that he is transmitting. Now status also will be 0. So this is what the way this guy is communicating, your Ethernet controller. To come to this page, first of all, you should learn about timer controller, interrupt controller, LCD controller. Once you have done everything, you can come here. But we should know that as a embedded system programmer, how this structured program is used. That's what the trick. What is happening after taking this packet? How this guy will know what is the next packet? Understand? What is the next packet? For that, this guy have one more field called next address. That is what this is 1000. This is 1020, 1040. So this will be 1020. So what after this transmit this packet, he will go and see that next packet 1020. So why we have this system is this guy will automatically go. Then here I say 1040. It will go. This is called linked list. This is called linked list. These are all fully automated. Yeah, this is called linked list. That's all. Thanks. Somebody has asked, is it called linked list? Exactly. Exactly. This is called linked list. Now, the beauty is this guy, when he comes to the last one, it will be FF. Once he reads FF, then he knows that, oh, this is the last one. Then what happened? He go back to the 1000. Then he will start. So this is all same structure. The structure will have a control. The control means, the control bit is 1 means send. 0 means in progress. Status bit is 0 means in progress. 1 means completed. This is the way the whole things work. You know, somebody will be, you may be reading that what is linked list and everything. Now I will explain to you that what is linked list. I have just given you the idea how that, see, the thing is that you should never underestimate use of C in the embedded system. Every bit of C is used in embedded system nowadays. So better master it. There's nothing called, oh, this is not used to anything. And we are using very advanced processor nowadays. So what is linked list? I have a memory. The memory, I have a structure. This structure has some elements. Now I have one more structure. I can say that, for example, let us see that I have a thing called structure ABC. Let's make this a int X, int Y, int Z. Let's take very simple one. So this is about long int. So now I'm using about 3 into 4, 12 bytes. 12 bytes. Now, if I say that structure ABC test of 3, it's array. I declare the array. When I declare the array, what happens? These things will be very contiguous. First 3 bytes. This is first one. 0th element. Test of 0. I have next one 3. Because if the array starts from 0 to 1, 2, that's why I given 0, 1, 2. So you understand now. I can do this. But unfortunately, the trick here is if I declare like this, so much of memory is already allocated. So people don't want to waste the memory. So what people did was very nicely. There is a function in C called malloc. What is that? Malloc. I do 12 bytes only because 12 bytes I need. Or I may say that size of ABC. So I'll take how many bytes now? Only 12 bytes. And malloc is the one, whenever I want, I can allocate the memory. That we will discuss later on memory structure. I have another session this week where we will discuss about heap, stack and everything. That time we will understand about malloc. So if you do any memory allocation, that is going to be fixed here. That is going to be wasted. I wanted to have a memory means I get allocated anywhere. If you request the system to allocate a memory, it will be various places. It will not be contiguous. When the memory is not contiguous, I cannot use arrays. Please understand, if you use array, it has to be contiguous. Since we don't use the arrays, that will not be contiguous. So what people did was, they have used this method here. This 12 bytes, they did it. Then they have another one called, see here, struct ABC star next. See that? Star next. The same. But now I have one more variable. This is a pointer. This is not structure, it's a pointer. What is this pointer? When you allocate first time, the address is 1000. Next time you get 1040. You get 2000. Now what will happen? On this, this address will be, what is? First one 1000. Next one 1040. This is 2000. Now, by using this structure next, we'll be able to walk through anything. Now, if I don't want this, I want to remove that. I want to remove this. Okay. Then what people do here is, I can remove this. I can put the 2000 here. See here, now this guy is linked here. I remove this guy. This is called removing from the link list. You remove an element from the link list. Same way you want to add. Very simple. What you do is you add, let's say previously this is 1040. And this guy is 2000. So this is what link was there. The link is here, 1000 to 1040, 1040 to 2000. Now you have to add one more. Now you added some more. One of my new element you added. That address could be 3000. So you put here, this guy could be 3000. You put 2000 here, you put 3000 here. This is what people test you in every company interviews. When you go there, they will ask you that, how do you create a linked list? How do you add an element? How do you remove an element? Okay. Sometime people also have the address of previous. You understand now? I will have, so every element know that who is before me, who is behind me. No, nowadays int means 4 bytes. We assume that int means 4 bytes. Okay. That's why all the avoiding the confusion. Nowadays, you suppose write a program called int underscore 8. Sorry, int 8t, int 16t, int 32t, int 64t. Understand? This is what nowadays people use. This is char. This is short. This is long. This is long. So understand now. So that's why companies everywhere, you will start seeing this nowadays. We don't use long, char and everything. The confusion will be always asking. You will be always having that whether int is 8-bit, 16-bit or 32-bit or 64-bit. But whereas this one is independent of, if you say that int 64 underscore t. This is always 64, even whether you use it on 8-bit controller or any compiler. In any compiler, use it, this is the way. You better use this. So, this is the trick here. Understand, I have so many people. Understand, I have about 5 people. I have 4 people. This guy name is 1. This guy name is 2. This guy name is 3. This guy name is 4. Understand now? They are about, let us make a circle. Let's make a circle. There are 4 people. Please understand this concept. That's why I didn't take this subject on that previous day. Now we have studied controllers, everything. We have come to the good level. Now this guy name is 1. This guy name is 2, 3, 4. Now this guy is communicating to this guy. This guy is communicating to this guy. Now, due to some reason, this guy is not well. He wanted to go away. If this guy wanted to go away, I mean, understand, this guy wanted to go away. At the same time, the link has to be perfect. For that, this guy, you should know that. The 3 guys should know what is the previous guy, what is the next guy. So, he will inform this guy, hey, I'm going off. So you communicate to 4. So he will say that, oh, I have to communicate to 4. He was initially 3. Now he will communicate to 4. Same way, he will communicate to this guy, hey, I'm going away. You communicate to 2. So now this guy previously will add about 3. Now he'll remove 3, 2. Now this guy will coolly get away. Now you see, hey, this guy knows that his next element is 4. This guy knows that his previous element is 2. Now that guy is coming back afterwards. Okay. When he comes back, this guy will be changed to 3. And this guy will be 3. And this guy will change 3. This is called you are adding a network. When you add, change these 2 people. When you remove, modify these 2 people. So this is called linked list. I know that. I'm very, very clear that you people got confused really. I don't worry. Once you have done a good programming, come back to me. I'll take this class once again. I will take this class a number of times till you understand, because this is very, very vital to get into some bigger companies. But if you start doing now this programming, you get confused. As I told you that, don't bypass a step. Don't first learn the first level, then get into the arrays, strings and pointers. Once you have done this, then come to the structure. It's clear. So, why I'm explaining this was how structure was used. The first thing what we discussed was, we have a structure for the microcontrollers. I have so many unit of controllers, timers. I'll have a structure called timers. I was using all of them by using each one is having a base address. I was using that. That's a very first use, easy use. The second use is, I have a controller. Example, we have taken example Ethernet controller. And the Ethernet controller sends a packet to the net. Now, this guy takes from memory the packets. But where the packets are available is available in the structure. This is called linked list. But the beauty is, you create the linked list on memory, you give only the starting address to this guy. Enough. You do not have to give everything. You do not have to program this guy, because this guy knows this address. This structure has the addresses. And this guy knows what is the next. So everything is self-contained. You have to tell the Ethernet controller only 1000. What this guy will do, he will read this and find out what is the next address. He will automatically take. He will do everything. That is a major advantage of the structures in embedded system programming. So if anybody have wanted to, after we complete the first set of programming, 50 programs, if you want it, let me know. I will start giving you the structure programming example, structure samples, exercises. Start from simple. I'll start from as usual. How we programming started. We start from a simple exercise. You start doing it, you will slowly learn learning your programming. This is a very, very important to learn structure programming. It's very important. But just because of it's important, don't come straight to this. You get confused. Do everything completely and come here. You know, why I have taken the class is a lot of people are thinking that these are all not part of embedded system programming. These are all part of high level C or something. No, no, no. These are part of embedded system programming, and these are all used by the embedded system companies. So in the interview, you say that I know linked list. You'll be very surprised. You'll be very, very surprised. In 2000, when I moved from hardware to software, that's the first time, the age of 37, I'm moving to hard software. Till the time I was a hardware engineer. That time, the company in US asked me only one question. That company manager asked me only one question. Balaji, do you know linked list? I said, I know linked list. He asked, if there's a problem with linked list, can you find out? I said, yes. Then he said, come for Monday. That they're not in check. Come on Monday. I went to Monday. Then only I realized there's a guy who has written a program for the Ethernet controller. The linked list was something wrong. Things were not working. Then I went and found the problem. And then they thought that, hey, I am a good software engineer. That's all. After that, I never turned back. That no, I'm telling you that. You know what is a year? 2000. I'm not talking about 2022. Please understand. I'm talking about the year 2000. We have used the structures in embedded. And you know that last 20 years, the development of that time ARM was not even popular. Almost, I was using another thing called PowerPC. This is another microprocessor. Okay, that's three people: Motorola, IBM, and Apple. All the three joined together developed this PowerPC. But why I'm telling you is this is the importance of C programming. I'm telling you that if you don't complete the first level and second level, you cannot come here. So how fast you do that? You come here. When you come here, you can move it to this one. I'll be here. I told you now. If you complete in 3 months, come to me after 3 months. If you complete after 4 months, you come to me 4 months. Okay. Watch the video. If you don't understand the video, then come and attend my class. Ask your doubts. Now I know that now nobody will be asking the doubts on this. It's because we have not practiced much about this on this structures. You may be now hearing about what is structure and what is that. But I'm telling you once again, listening this class or watching the YouTube videos does not make any sense on structured programming. This is a very important one, very easy one. Start practice. But to come to the level, do all the sums. Okay. Now let us take a break for about 5 minutes. Then, even though I know that I have to discuss about 2 more topics, unions and enums. Next session, we'll discuss about first preprocessor. That's important. That's why I'm discussing. You'll be using the preprocessor, then you'll be using the enums and unions. So after discussing preprocessor, if I have a time, I'll explain the union. Otherwise, I'll explain to you on the next session. Because I know that this takes slightly more time, that structure, but the structure alone, I can able to spend about 1 week. Structure alone more than a week. But don't leave it. Your goal has to be 100% understanding of structures. Your goal has to be 100% understanding of structures. That gives you the excellent ability to travel into the embedded world, high-end embedded world. Okay, so, but don't bypass. There's now no shortcut. That I never agree. Never shortcut. Go with the, take your own time, practice more time and go into the thing from the bottom to top. Don't bypass. So next session, we are going to discuss about pre-processor. That please is a very important. Everybody, whether you attend this session or not, doesn't matter. Pre-processor will make your programming style totally different. So please let us spend some time on pre-processor now. Okay.